radicals. So we're going to start working with radicals, and we're going to be simplifying radicals. We're going to be adding, subtracting, and multiplying with radicals. As we do that, we want to make sure that we've got some of the basics of radicals covered. You should have a sheet that says the basics of radicals. That's going to go into your reference notebook for you to go back to. It's got all the basics that we're going to cover in this chapter in one place. Some of the pieces that we need to know right now. We're mostly going to be talking about the principal square roots of our radicals, so that if I'm squaring if I have a number squared and I find its square root, I'm looking for only the positive square root. I do not want to have a negative square root. I'm only looking for the positives. And then some of the basics of when we get to our final answer, and I want to make sure that I've simplified it as much as I can. Note, a radical expression is in simplest form when no radicands have perfect square factors other than 1. So I want to make sure that in my radical symbol I don't have any perfect square factors that I've left. 2, no radicands contain fractions. So inside the radical sign I don't want to have any fractions. And thirdly, no radicands appear in the denominator. So I do not want to have any radical symbols in the denominator. And again, as we think about, we only want the principal square roots. If I find the square root of a power that has an even power, and I find that its square root has an even power, I can leave that way, because then I know that if I'm doing something squared, something to the 4th power, if it was negative to start with, I don't need to worry about it. It's going to be a positive. That'll be my principal square root. However, if when I take a square root out, it starts out as an even, which is the only way I can find its square root, that makes a perfect square. If I end up with an odd power on my outside once I've found its square root, I need to use the absolute value symbols so that I know I have a principal square root. So if it's even when I start, if I take that, if my square root ends up with an odd exponent, I need to find its absolute value. We'll put that into play in a minute as we get going here, but these are our basics. Keep this in front of you so that you kind of are starting to remember them and starting to keep pulling back to them. All right, so let's get into our actually simplifying radical expressions. The product property of square roots is what we're going to use for the most part to simplify our radicals. In words, for any non-negative real numbers a and b, the square root of ab is equal to the square root of a times the square root of b. So if we do this in symbols, the square root of a, and that's a times b, equals the square root of a times the square root of b, as long as a and b are both greater than 0, which makes sense because I can't find a square root of a negative. And for an example, the square root of 4 times 9 is the square root of 36, which is 6. But we could also say the square root of 4 times 9 is the square root of 4 times the square root of 9. That's 2 times 3, which is also 6. So I can break it up that way. All right, let's use that as we take a look at some of these radicals and simplify them. So the square root of 54. So the square root of 54, what I want to do is take each constant that I have and find the largest perfect square factor that I can find. Don't find the smallest. That's not going to be helpful. You want to find the largest perfect square factor. So 54 is 9 times 6, and I know that I can break this up into the square root of 9 times the square root of 6. The square root of 9 is 3, so we say that the square root of 54 in radical form is 3 times the square root of 6, or 3 radical 6. Next, square root of 180. So again, I want to break this up into the largest square root factor I can find. Now I could have broken this up into 9 times 20, but 9 is not, 9 times 20, but 9 is not the largest perfect square factor I can take out of that. I can actually take out a 36. Now if we broke this up into 9 times 20, you'll notice that 20 also has a perfect square factor, and it has 4 in there. So the 9 times the 4 gives me that 36, with that 5 hanging out on the end there. So I've got 36 times 5, square root of 36 times the square root of 5, square root of 36 is 6. 6 times square root of 5 is this radical form of square root of 180. All right, let's do a little multiplying here. The square root of 5 times the square root of 10, that's equal to the square root of 50. Now I'm going to try to take out any perfect squares I can. The largest perfect square is 25. Square root of 25 is 5, so I can pull a 5 out of there, and I end up with 5 times the square root of 2. And again, we want to be able to look inside these radical signs and make sure there's no perfect square factors there. And the last one for this, we've got the square root of 6 times the square root of 8, which is the square root of 48. I can break that up into 16 times 3. Square root of 16 is 4, so 4 times the square root of 3. All right, let's get a little more complicated. Whoa! All right, so what we're going to do here is now we've got not only our constants but our variables in there. So I'm going to break this up one piece at a time. Now, just like with the ones we just did, eventually you should be able to get to the point where you can kind of do some mental math with this. But for now, I'm going to, and you don't have to, but I'm going to kind of write out piece by piece as I deal with each of the factors in here. So 56. Square root of 56, I can break that up into 14 times 4. So 14 times 4 is 56. Square root of 4 is 2, so this is 2 times the square root of 14. And again, this is going to be kind of calculator. You're going to play with your perfect squares there. Square root of x. Well, that's not a perfect square. There's no perfect square factors in it, so the square root of x is just the square root of x. Now, the square root of y to the 10th power. Any even power is a perfect square. So half of that power is our square root. So y to the 10th, the square root of y to the 10th is y to the 5th, because y to the 5th times y to the 5th is y to the 10th. Remember, number times itself is always squared. Now remember, when we go back to, we want those principal square roots here. This y to the 5th could leave me with a negative, and I don't only want the principal square roots, I want positive. So we're going to absolute value it. So again, if I pull it out and I get an odd exponent on that square root, then I want to put the absolute value symbols around it. Z to the 5th equals z to the 2nd. Z to the 5th equals z to the 2nd times z. So again, I can break this up into z to the 4th times z. So I end up with z to the 2nd times my z. All right, so I'm going to put these back together, these ones that are here on the right. So my 2, my absolute value of y to the 5th, and my z squared are all on the outside of my radical symbol. Inside my radical symbol, I have 14x and z. So 14x and z inside my radical. So there is the simplest radical form of this original radical. One more. So I've got 4k squared t to the 4th, all in the radical symbol, times square root of 32r squared k squared times t. I'm going to put these all together first so I can kind of see what I have in one fell swoop here. And then I'm going to deal with each one individually. So I have square root of 128, and the square 128 is 64 times 2. So 64 is a perfect square, so that's 8. So 8 times the square root of 2. K to the 4th, perfect square of k is a perfect square. Square root of k to the 4th is k to the 2nd. R to the 2nd, that's a perfect square also. So it comes out as r. Now, this is an even on the inside, but it's an even on the outside, so I don't need my absolute value symbols. This is an even on the inside, but it's an odd on the outside, so I need those absolute value symbols. All right, and my next one, t cubed. T cubed breaks down into t squared times t. T squared is a perfect square, so that comes out as a t, and I have one t inside. Now notice that this is an odd on the inside, so I don't need to worry about my absolute value symbols. If there's an odd exponent on the inside, and think about it, if this is odd here, this can't possibly be negative, because if it was a negative, I do a negative times a negative, positive, times a negative again, and this would be a negative inside, and I can't have a negative inside a square root. There's no solution to that. So this can't be a negative in any way, shape, or form, so it's automatically positive, so I don't need to worry about my absolute value symbols. All right, so let's put this back all together here. I've got 8k squared and absolute value of r and t on the outside of my radical symbol, and inside my radical symbol I have 2t inside my radical symbol. So each factor one at a time, we are finding its simplified version in radical form.